Hey guys. Okay, today is October 2nd, and you just finished your mid-unit test on linear equations, systems of equations. Today, or right now, you are going to take some notes on linear inequalities. So, as I told you the other day in class, it is very important that you know how to graph a line. Again, if you are struggling with graphing a line, you need to do some work this weekend. Either go Google it, watch it on YouTube, rewatch my videos, go to Khan Academy, just pull some resources and make sure that you understand how to graph a line, a linear equation. So, now, linear inequalities. The notes are going to be brief because, again, it just is one slight change in a linear equation. So, as you know, a linear equation takes the form of y is equal to mx plus b. That is slope-intercept form. M is your slope, b is your y-intercept. Okay, so a linear inequality obviously is going to be a linear equation, but instead of the equal sign, it's going to have a greater than, a less than, a greater than equal to, and a less than equal to. So let's just talk about just normal inequalities. If I give you a greater than or a less than symbol, as you know, if you were to graph this on just a number line, you would have an open dot on the number. Well, with a linear inequality, it basically takes your coordinate grid and breaks it into two half planes. You'll have your line that you graph, which is your solution, and now your inequality, you will either shade above it or below it. Okay, well, if I give you a greater than or a less than symbol, you are going to have a dotted line. A dotted line. Because what this means is it does not include the line as part of the solution set. Because as you know, let me just write that down, does not include the line as part of the solution set. Because as you know, when you graph a linear equation, that line represents the solution to that linear equation. So now we're dealing with inequalities. So if it's a greater than or a less than, then it's a dotted line. So that line will not be a solution. Now, if I do greater than equal to, less than equal to, that's going to be a solid line. And it includes the line as a solution, as part of the solution set. Okay, so now let's look over at the reading strategies sheet that you picked up, page 17. Okay. I want to look at number 4, and let's just graph it. Let's not worry about, let me zoom in a little bit. I don't know if I can, I think, there we go. Okay, so when we just graph this line, what do I know? I know my slope is negative 1/2, and my y-intercept is 0,3. So 0,3. A negative slope means I'm going to go down 1 and right 2, up 1 and left 2. Take your straight edge. Now looking at your inequality sign, it's greater than equal to. So we know it's going to be a solid line. So that is, if you think about it, the same as y is equal to negative 1/2 x plus 3. Now, because it's an inequality, it's everything, and if you look, it says greater than or equal to this line. Okay? Well, if it's greater than the line or equal to the line is going to be solid. Greater than means I'm including every solution that is above the line. Every solution above the line. So if you were to pick a point up here, okay, whatever point that is, which if you look is, what, 5, 9. Okay, 5, 9. And I look in here and I say, you know what, I want to go over here and plug it in and see. Okay, well, plugging it in, y is 9. Is 9 greater than or equal to negative 1/2 times 5 plus 3? Well, 9 is greater than negative 5/2 plus 3. I'm going to turn 3 into a fraction with a 2 in the denominator. So as you know, that turns into 6/2. So now negative 5 and 6 is 1/2. Is 9 greater than or equal to 1/2? Yes, it is. Now let's just choose a point over here. So if this is true, then obviously this should be false. But let's just verify it. So this point is negative 6, negative 3. So plugging it in, negative 3 is greater than or equal to negative 1/2 times negative 6 plus 3. Simplify. Negative times a negative is a positive. And 3 plus 3 is 6. Is negative 3 greater than or equal to 6? No. So we know that we did it correctly. Again, the easiest, like I said, greater than means above. Greater than equal to means a solid line. Okay? Now, if greater than is above, then what do you think below the line would be? Okay, and hopefully you said less than. So looking at this equation right here, before we even graph it, you can go ahead and say what the graph is going to look like when it's finished. Well, it's less than, so we know it should be a dotted line, and we are going to shade below. Okay, because it's less than is below the line. Okay, so let's plot this. My slope is 1, my y-intercept is 0, 5. So plot 0, 5, walk out your slope. Up 1, right 1, down 1, left 1. It's a dotted line. So you should have a dotted or a dashed line. And again, any point on this line will not make this true. Now, less than, so everything below. So if I choose a solution in here and I plug it in, it should be true. If I pick a solution here and plug it in, it should be false. Okay? Now, I want you to go up here, and on 1, 2, and 3, I want you to tell me if it is a solid line or a dotted line, and if I'm shading above or below. So pause the video real quick, and then answer those 3 questions, and then come back and make sure you did it correctly. Okay, so on number 1, it's less than or equal to, so it's going to be solid, and it's below. Greater than negative 5, or excuse me, greater than negative 5x is a dotted line, and I'm going above. Greater than equal to, solid, and above. Okay. Now, so go back in your notes and let's talk about shading. And we just said if it's greater than or greater than equal to, we are going above the line. If it's less than equal to, we are below the line. Okay. 2 things I want you to think about. Okay, if I give you as you know, that is an undefined slope. Where would above the line be? So if I had a greater than or a greater than equal to, where would I shade? And then the second thing I want you to think about, obviously, if I gave you less than or less than equal to this line, where would you shade? So what I'm saying, if x is greater than 3, where would you shade? And if x was less than 3, where would you shade? Okay, I hope y'all have a great weekend, and I will see you on Monday.